Welcome to, it should say, part 3 of 2.8 Modeling Variation. Our central question is, how can two functions be combined? We're going to talk about the last way this time. So a joint variation is a variation in which variables vary directly as the product of two or more variables. Thus the equation y equals k times x times z will read y varies jointly as x and z. So let's look at this problem. The volume of a cone V varies jointly as its height h and the square of its radius r. So our equation right there is V, don't forget your constant, varies jointly as its height and the radius squared. So we had that it varies as the height and the radius squared. So now we're going to fill in the pieces. A cone with the radius measuring 6 feet and a height measuring 10 feet has a volume of 120 pi cubic feet. That means we have 120 pi equals k times your height times your radius squared. Now we're going to solve for k. I'm going to rewrite it over here. So this means in the end we'll have k equals pi divided by 3. So my constant is going to be pi over 3. So let's rewrite our equation. Volume equals pi over 3 height times radius squared. So that was your volume equals pi over 3 times your height times your radius squared. So it says find the volume, so we're looking for volume. Constant's always there. The radius 12 and the height of 2. So now we just solve. We'll make it all over. So your volume in the end will be 96 pi. So the volume cone is 96 pi, we're just going to leave it in pi, feet cubed. Make sure that you answer the questions below and you complete your homework. Also come to live class. This is the last section of Chapter 2, so there is a Chapter 2 test for you to take as well.